Okay, in this vid we are going to cover functions and classes. We've gone over functions a bit already. Functions begin with the function keyword. There's an optional name of the function. Optional parameters go inside of parentheses. Curly brackets denote the code that goes inside the function. You can put as many lines of code as you want in a function. They can get really huge. You can nest functions inside other functions. And you can optionally return a value in the function. We'll go over those three cases in a second. And then you can call the function by using the name of the function and then optionally passing parameters inside using the parentheses. So if we run this, it'll alert hi. This is what's called a function declaration. That's kind of the more normal way you'll see a function. But you can also set an entire function equal to a variable like this. Here, alert variable equals function, and then we call alert variable with parentheses, and that'll do the very same thing. You can return a value in a function. Whenever the return gets called, the function is exited immediately. You can optionally return a value. You don't need to. So if you do return a value, the entire function ends up equaling that value, whatever it is. And you can also have like an equation in here, and then whatever that equation boils down to is what gets returned as well. So in this case, we're setting a variable equal to the function, and then we're alerting the variable. You can do nested functions. Functions inside function. Here we call simple addition, which goes down, says x is equal to 2 plus 2, 4, and then here it sees this function, but it doesn't get called until here. Here it calls the inner function, make alert, and it says alert x, so it'll alert 4. Functions have optional parameters. The parameter name goes here, and then you can call the parameters, or you can use the parameters inside the function. So when you call the function, you pass in the parameters that you want to use. So here we're saying x is equal to 2 and y is equal to 2. And then when we use x, it's 2 and y is 2. Okay, you don't see this a lot, but you can totally use an arguments property of your function and call like arguments.length, and it'll tell you how many parameters got passed in. You can also use arguments as an array and say like arguments index 0, and it'll tell you the value of your first argument. So it can be very helpful. So if we run this, first it's saying there are 2 arguments passed in. Then it's saying the first argument is 2, and then it says the second argument is 3. You don't see this very often, but you can make your number of arguments variable. So in a case like this, all the variables are optional. We can run this with no arguments or with as many arguments as we want. Here we've passed in 4 arguments, and then using the arguments property, we're saying, hey, add whatever the current argument is in a for loop to a running sum. So in this case, we're going to get 1 plus 2 plus 3 plus 4, which is 10. Okay, you can also do recursive functions, functions that call themselves. In this case, we're running this function called recursive. We're passing in an argument of 1. So we're saying log out x, and x is equal to 1. So we'll get 1 in the console log. Console.log gives you information. If you do, like in Chrome, Control-Shift-I to bring up the DevTools and then hit the console tab. So if you do console.log, it'll print info here. So we're saying log out the value of x, then add 1 to x, and if x is less than or equal to 5, then run recursive again. And notice we're running it from within itself. So when we run that, we're just going to see 1 through 5. Okay. Okay, there's something really weird here called an IIFE, IIFE, instantly initiated function expression, something like that. So the whole function is wrapped in parentheses, and then if you want to pass an argument in, you can just put it in parentheses after the initial parentheses, and then the first thing would be the first parameter, and etc. So in this case, we actually never call this function. There's no name for it. We never call it, but it's instantly invoked because we've wrapped it in an IIFE. We've wrapped it in these parentheses. Okay, so the IIFE is leading up to closures. This is kind of advanced stuff, but it's super good to know. So this is a simple closure here. The real simple definition of closure is that every function has closure, and that just means it has access to the variables outside it. So in a technical sense, like top-level functions have closure, but you don't use that too much. When people talk about closure, usually they're talking about nested functions, and they're saying that that the inner function has access to these variables. And the variables, well, okay, so in this case, we run this, and it does what we would expect. But closures get real interesting in a case like this. I'm going to make this bigger here. So this code does not do what it looks like it should do. Here we have a bunch of boxes, 10 of them, and our script says on window load, run this function, and the function just says from I is equal to 1 to 11, or 1 to 10, grab the box with the ID of box I, and then when that box is clicked, alert you've clicked on box I. So you would think that this would alert like you've clicked on box 1, box 2, box 3, but it doesn't. If we click on box 1, it says you've clicked on box 11. If we click on box 2, it says you've clicked on box 11. Click on the last box, it says you've clicked on box 11. So why is that? Well, the solution to this is to get closure on it. So here's the same code, totally the same code, but we've added the inner function is returning a value. So as soon as we do that, these variables now get scoped to when they were called. In the previous example, what was happening is the whole thing got run, and then this just came out. You've clicked on box 11 on the last number, because the variables weren't getting scoped to the time when this was actually run. So in this case, when we click that, it's actually going to remember what the index was when we clicked it, because we've given it closure now that we've used this return value. So that's what closure is. Notice that we've used an IIFE here. Here's the opening parenthesis in the IIFE, here's the closing one, and then here's that final parameters or arguments parentheses. So we're passing an I, and now I gets remembered because we've given it closure. Okay, let's get into classes here. So with classes, we can do something like we can make a class of mammal, and then we can like instantiate that class into objects as many times as we want. So we could have like 10 mammals. We can also subclass that. So we can like take the mammal class, subclass it into like dog, and then instantiate that into dog. And we can have like cat. We can keep going into stuff like that. So here's a class for a rectangle. And notice that we're saying this dot width equals W. So we already have the W, but we have to say this dot width because when it gets instantiated, we want it to be able to have a different width then the next instantiation, something like that. So here we're instantiating it. Rectangle 1 is a new rectangle. Width is 2 and height is 4. And then we're saying alert rectangle W. Okay, I had to fix that. Here we're saying alert rectangle 1 dot width. So we get a width of 2. Okay. So these are called instance properties. This is a class with a property. We can talk about instance methods. So this is how you would think you'd make a method. Since a property is just a variable here, like this dot width, you'd think you could make a method or a function inside your class by doing this dot whatever equals your function. This actually works, but it's not what we want because this is very inefficient in terms of memory. So here, every time we instantiate this guy, it's going to have a unique width and height value, which is what we want. And then this is also going to have a unique area. So each instance is going to have this area method copied to it. And really what we want, since this is never going to change, this is just an equation, not specific variables. We want this to be passed by reference, not by copy. So the correct way is this. So when we do this, we're setting the prototype of rectangle equal to our method. And now when we instantiate it, it's going to get the method from the prototype, which is good, and then it'll be passed by reference. So we only have one copy of this function in memory instead of the same number as how many instances we have. So this is an instance method. Let's talk real quick about this prototype thing. Okay, so whenever you have an object in JavaScript, or whenever you let's see here. Yeah, whenever you have an object, JavaScript is going to actually create a second object, which is accessible through the prototype property. So we have like rectangle, and then we have rectangle.prototype. Now, when we instantiate another object from rectangle, so if we make like rectangle 1, it's going to get all the properties inherited from rectangle, from its constructor. So that's a little bit on .prototype. That stuff can get really complicated. You can do .constructor, you can do .prototype.constructor. We'll go over all that in another video. There's some interesting charts that chart all that stuff out in JavaScript. But that was just a quick intro. We'll also revisit it in a little bit here. So we were talking about instance properties and instance methods. We can also talk about class properties. Actually, first let's talk about extending built-in classes. So string is a class, which is built into JavaScript. It's just like our class, except it's built in. And just the way we can modify our class by doing .prototype and adding a method, you can modify a built-in class doing the same thing. So here we have string.prototype.endsWith equals a function, and then when we run the function, it says true. Okay, class properties. So if we return to our little rectangle and our little method here, we can add a class property directly on the class. So this is just saying rectangle.unit. The nomenclature is usually all upper caps, and then this is a little property. We can also have class methods, something like date.getDate, super common. That's a class method. Okay, in JavaScript you have private properties by... Okay, sorry about that, I screwed that up. So private properties, if we, instead of just saying this.width equals a number, if we say this.getWidth equals a function which returns that number, it becomes a private property that can't be altered outside the function. So we can't say like get width equals something. You can only say immutable rectangle and then pass in our value. So that's a private property. Okay, let's talk about extending classes real quick. So what we're going to do here is extend our rectangle. Here's the original rectangle, properties and methods. Okay, now here we're going to extend it into a position rectangle. So what we want is an XY coordinates, and then we're also going to take the same width and heights. So we're saying, here's the extending part. We're saying rectangle, which is this class, call this, and then we're passing in width and height. So when you do call this, we're calling rectangle, and then we're passing position rectangle through it when we instantiate it. So the this dot width in that case will be the this dot width for position rectangle. And then we're also adding two new properties, this dot x equals x, this dot y equals y. So that's how you start extending it. There are a couple extra things we got to do to wire this thing right. We got to say position rectangle prototype equals new rectangle. Otherwise the prototype won't be right. So this is all the weird stuff you got to do in JavaScript behind the scenes to get class type stuff. We're really it's really a pain in the butt compared to other languages. Here we're going to delete the position rectangle prototype width and the position rectangle prototype height because we actually don't want the width and height from this guy. And then lastly, we're going to set the constructor. So it's positioned rectangle, no space in there. Position rectangle prototype dot constructor equals position rectangle. Yeah, that's right. So that's how you do the subclassing and the extending classes in JavaScript.